Okay, hello, welcome back. So this time we'll work on a problem here from India. That is the Indian JEE Advanced 2019 question 17. JEE stands for the Joint Entrance Examination for the Indian Institute of Technology, one of the top university in India. And this is the problem. We have to compute this definite integral from minus pi over 4 to pi over 4. The function is 1 over 1 plus e to the power of sine x times 2 minus cosine 2 of x. We have to compute this definite integral. Now, let me tell you that I can rate this problem. It's not so difficult and not so easy also. So let us start to solve this. But before solving this, before seeing the solution, you might want to try to solve this by yourself as an exercise. Okay. So now before solving this, we must think for the strategy to solve this definite integral. What we want to do with this integral. Now let us look for patterns from this integral that might help us to solve this problem. First thing, notice that the boundary is from minus pi over 4 to pi over 4, right? That is from minus some real number up to that real number, minus L to L. Okay, so that is the first pattern. And then it also involves two trigonometric functions, sine x and cosine x. We have an odd function, sine x, and even function, cosine of x. And relating to the boundaries, we have sine L is equal to minus sine of minus L. And then cosine, also cosine L equals cosine minus L. Okay, so these are two important information for us that might help us to solve the integral. And then we also have here 1 over 1 plus e to the power of sine x. We have 1 over 1 plus e power of sine x, and that is of the form of 1 over 1 plus a to the power of b. And if we combine this with the 1 over 1 plus a power of minus b, we can actually combine them. We can add them up. We can add them, and as you can see here, the addition here, it is clearly 1. It is equal to 1. Okay, so we need to find a way so that we can use this addition. We need also, in other words, we need also 1 over 1 plus e to the power of minus sine x. We need that too. But as you can see here, we might want to relate to this pattern right here. Okay, so these are all important. Okay, next. Now, let me break this integral into two parts. That is the negative x minus pi over 4 to 0 and the positive x from 0 to pi over 4. Now the first one, I will call this I1, and we will work on this part only. We will just leave this one right here. We leave this one. Okay, for the first one, let us use the substitution u equals minus x. This makes sense because we want to use the pattern, right, that we have just described in the previous slide. So I want to use substitution u equals minus x, and by the substitution, this means that dx is equal to minus du. Easy to check. And then notice that the boundary will also change. Initially, we have x is from minus pi over 4 to 0. And then we want to change in terms of u. It will be from pi over 4 to 0. The boundary of the integral. Because when x is minus pi over 4, u, which is minus x, will be pi over 4. So this one will be pi over 4, and then when x is 0, the upper boundary, when x is 0, u will also be 0. So this one will also be 0, the upper boundary of u. So we have this integral right here in terms of u. from pi over 4 to 0 of minus du over 1 plus sine minus u, because x is minus u, and then times 2 minus cosine minus 2u, because x is minus u, and the dx is just minus du. That is easy. Okay, so now let me just rewrite this in terms of u now. Now this red one, we focus on this one, we just leave the other one. Okay, and since sine is an odd function, so sine minus u, it is equal to the minus sine of u. And also the cosine minus 2u, since cosine is an even function, it is just the same thing as without the minus sign. So I change this into minus sine u here, and cosine minus 2u becomes just cosine 2u. The next thing I want to do is, I want to combine these integrals back, but the boundary must be the same. So I want to change this into from 0 to pi over 4. Now we can do that, we can flip this, but we must multiply by minus 1. That is the rule, right? We must multiply by minus 1 if we want to flip the integral back. And we get this, and we have now the same boundaries for both integrals. So let us compare these two integrals. What are the differences? Okay, but before that, since u is just a notation, x and u is just a notation, variable, symbol, so I can just change this u to any other letter, whatever you want, but in this case, I will just use x for consistency. And okay, so what are the differences between these two integrals? The 2 minus cosine 2 of x are the same. The numerator also the same, that is 1. But this one, 1 plus e power of minus sine x, is different with 1 plus e power of sine x. That is the only difference. And let us combine them, add them up. Now this addition here is exactly of the form 1 over 1 plus a power of b plus 1 over 1 plus a power of minus b. And it is equal to 1. So we can use this, and this integral becomes much more simple. So we have simplified this into the only 1 over 2 minus cosine 2 of x. Okay, so this is only halfway done. We only simplified the integral. Recall that this is our main problem here, the left one, and we have changed this into much more simple form. And this is halfway done because it is not also easy. It's not easy to compute this integral. We must know some techniques. Now to solve this integral, we just write this as 1 over 1 plus 2 sine squared. We can do this because cosine 2 of x is just cosine x plus x. That is cosine squared minus sine squared. I will leave this to you to check that these two are equal, because as an easy exercise for you, that is quite easy. And then again, I just divide the numerator and the denominator by cosine squared. I divide both the numerator and denominator by cosine squared, so I get this becomes tangent squared of x, and this is secant squared, and this is secant squared. And then using another trigonometric identity, secant squared is equal to 1 plus tangent squared. So I get this form right here. And now we can use another substitution. Let u to be square root of 3 tangent of x. So the dx will be, this is just 1 over square root of 3 times secant squared x du. So we can cancel the secant squared in the numerator now. We can cancel them, so it is just 1. And in terms of u, I have here 3 tangent squared of x. This one, 3 tangent squared of x, is just u squared. So we get this in terms of u, and this will be easy. this is just tangent inverse, right? Tangent inverse of u. So we get here 1 over square root of 3 times tangent inverse of u. And changing the u back to x, we have square root of 3 tangent of x. So we have this is equal to this. Okay, so we don't have integral anymore now. It is now we already compute the indefinite integral. So let us just plug in the boundaries now from 0 to pi over 4 here. This is the result, right? The indefinite integral. So we have to plug in now from 0 to pi over 4. We get this form right here. That is easy. That is clear. So we have to compute each of these terms right here. Now for the tangent inverse of square root of 3 tangent of 0, that is equal to 0, because tangent of 0 is 0, right? And so this is 0. And tangent inverse of 0 is also 0. Okay, and then, well, actually, it has many values, but I take 0 here. I will take the 0 value here, and then the tangent pi over 4 is exactly 1. That is easy. And then so the tangent inverse of this one right here is just exactly tangent inverse of square root of 3. And this is also easy to compute because we know that sine 60 degrees is equal to square root of 3 over 2 and cosine 60 degrees is half. So this divides this is just square root of 3, right? So the inverse of square root of 3 is just pi over 3. And so we have done. The answer is 1 over square root of 3 times tangent inverse of square root of 3, because all of this is 0, right? And this is 1. And that is exactly pi over 3 times square root of 3. So this is the final answer of this JEE problem.